Okay, today we're doing Unit 7, Section 6, Solving Radical Equations. Now you're going to have to use all your knowledge of how to solve equations and all the rules that you've known so far about algebra solving equations in this. You can't just forget what you've already learned. Like if you add something to one side of the equation, you have to add it to both sides of the equation. You have to undo one side. If you undo a square root, you have to undo the square root on the other side of the equation. You have to make sure you're keeping it balanced. That's the big deal. Okay, there's 4 quick steps you can do this. And the first step is to isolate the square root on one side of the equation, if possible. And I'll show you what I mean by that. In other words, we don't want any like plus 3 on the outside or anything like that. We kind of want the square root all by itself, okay? And then step 2, and these are quick steps that I'm just kind of giving you an idea. You're going to square both sides of the equation to get rid of the square root. That's why you want it alone. So that'll get rid of the square root. That may create another issue on the other side, another algebra problem on the other side that you're going to have to work through. But that's how you're going to get the square root going, is to square both sides. Step 3, we're going to solve for the variable using the rules of algebra, just like you've always done. Now, if you were having trouble solving multi-step equations, now's another time to practice it so that you know how to do that, okay? And step 4, this is a big part that people like to skip, and this is check for extraneous solutions. So what happens, extraneous, it's just a fancy word for extra or ones that don't work. When we square both sides of the equation, sometimes we produce an answer that doesn't work with the original equation. Because we've manipulated it, we now have a solution that doesn't really work with the original. So we have to go back and make sure we didn't create an extra solution that doesn't work. So you do have to check it, okay? So I'm going to do a couple problems with you, and I'm going to tell you what step I'm doing first as we go, okay? And if you need to pause it, and then, continue with me. Example. Number 1. I have 5 equals root x over 4. My first step that I gave you was to isolate the square root. Isolate means get it by itself, okay? If there's anything outside the root, you want to move it to the other side of the equation. So we're going to get the square root alone. That's what I'm doing right here. This is step 1. And in order to do that, I need to follow the rules of algebra. Well, what in the world is over there with the square root that's in the way? And in this case, it has a denominator of 4. Well, what's another way of saying it has a denominator of 4? Another way of saying that is that we're dividing by 4, and we need that gone. So we're going to do the opposite operation. That's how algebra works. So I'm going to multiply by 4. But whatever I do to one side of the equation, I have to do to the other side of the equation. And so I'm going to multiply the other side by 4. Okay? Now let's see what that does for me. That leaves a 20 equals 4 over 4 cancel out, so now we're just left with the square root of x. So we've done our first step, which was to get the square root alone. The square root is now alone on one side of the equation. Now really what we're doing at this point, we're starting to solve the equation. And I did make that a step because this is a relatively new step to our solving equations. And that is we have to get that x out from under the square root. Well, in order to do that, we have to do the opposite operation, just like opposite operation of multiplying is dividing, adding, subtracting. Opposite of square rooting is squaring. So we need to square, and if we're going to square one side, we have to square both sides to keep it balanced. So I'm going to square both sides of the equation. Now some people get confused and think, well, doesn't that bring a plus minus? No, it's the square root that brings a plus minus. So we don't have anything to deal with plus minuses here. We're just squaring both sides, okay? Now remember what that does. That means 20 times 20, not 20 times 2. So that gives me 400 on this side. And on this side, if we're squaring a square root, we're undoing it. So all that's left is x. So we have x equals 400. We're not done the problem though. Okay? So we squared both sides. Our x is already by itself, but our last thing is to check it. And when we check it, I'm going to show you how I want to see it. We're going to take the original equation. The original equation was 5 equals the square root of x over 4. We're going to replace the x with what we think x should equal. In this case, we figured out by using algebra that x equals 400. This is not a solving, so we're not moving things from one side to the other. Be careful of that. So here's how I remind myself we're not doing that. I'm asking the question, does 5 equal the square root of 400 over 4? Are they the same? So let's check it out. I'm going to get, again, I'm not moving to the other side of the equation. I got my calculator out in case I don't know, and I do the square root of 400. And the square root of 400 is 20. So then the question is 20 over 4 equal to 5? And the answer is yes. And this is how we note it. We say 5 equals 5, check. Therefore, this is not extraneous, and that's the solution. If it were an extraneous solution, I would cross it out or put something like extraneous solution, extra solution, okay? So that's the first problem. Just using your algebra skills that you've learned all year long, we just have a couple extra steps in there, okay? Let's try number 2. Example number 2. We have the square root of x plus 1, so you can already see we're stepping it up a level. On the outside, we have a plus 7, and that's equal to 10. Okay? The first step I told you to do with these, and this is where I really see people making mistakes, they try to square both sides right here. If you try to square both sides right here, you will make a giant mess. Okay, so you want to move that plus 7 out of the way. Well, how do we do that? We move it to the other side of the equation, which means we need to subtract 7 from both sides. Okay, so now I have the square root of x plus 1 equals 3. Now I've isolated my square root. Now that I've isolated my square root, I can square both sides. I just need to get that square gone. So I'm going to square both sides. The square root being squared results in x plus 1. 3 squared is 9. We don't have x by itself yet, but this is a one-step equation now, and for those of you who are used to me, I always draw a line when I'm solving an equation to remind myself I need to move it to the other side. So I'm going to subtract 1 from both sides, and I get x equals 8. That's great. X equals 8, maybe. We have to check it. So we go back all the way to the original problem from the very beginning. The original problem was x plus 1 minus 7 on the outside. I'm sorry, the square root of x plus 1 plus 7 on the outside equals 10. Now I'm asking, is 8 the right answer? So I'm going to put 8 in there for the x because that's what we think. When we solved this algebraically, we said, well, we think algebraically that x equals 8. So let's see if that's true. So I have 8 plus 1 underneath the radical, plus 7 outside the radical. And now I'm putting that question mark to remind myself I'm not moving things from one side to the other. I'm checking one side to see if it's the same as the other side. So you could do this in a couple steps. You could do it in one step. I'm going to do it in a couple. The square root of 9 plus 7, does that equal 10? So does 3 plus 7 equal 10? Yes, it does. So 10 equals 10. Perfect. That is not extraneous. So that is our answer. Okay? We checked it. If you don't check it, that's half the problem. You're going to lose a lot of points by not checking. Okay? And we're going to do a bunch of examples here. Number 3. So you could always pause the video right now and go with your homework and do some of the ones that I just taught you, some of the easier ones, okay? And then come back and watch the next couple examples as you get to the more difficult problems. Number 3, the square root of x plus 2 equals x minus 4. All right, well, my square root's already isolated. So we need to square both sides. Now be careful. I told you before, this is a chunk. So when I square both sides, I have to actually square both sides completely. And so this side gets squared and this side gets squared. So on the left side, that's pretty easy because the square root squared just undoes itself. So we're just x plus 2. Now be careful on this one. X minus 4 squared does not equal x squared minus 16. That is a pet peeve of mine. It equals x minus 4, parenthesis, another x minus 4. You have to FOIL or box it, okay? And so some of you may be seeing this is not going to be as easy as the other problem. So what you have then is x squared minus 4x minus 4x minus 16. And some of you don't need the step I just did. That's okay. So I have x plus 2 equals x squared minus 8x minus 16. At this point, I hope some alarms are going off in your head and you're thinking, oh crap, this is a quadratic. If it's a quadratic, we can't just move x's to one side. We can't just try to square root. We are going to either have to, quadratic formula, complete the square, factor. We're going to have to do one of those things, so just get over it. If you're one of those people that never learned how to factor, you might want to learn how to factor at this point because most of these are factorable. So what I need now, and if you remember back to that unit, I think it was 4B, in order to solve a quadratic, if you're going to factor or use quadratic formula, you have to have it equal to 0. So I'm going to subtract x from both sides, and I'm going to subtract 2 from both sides. And that'll give me 0 equals x squared minus 9x. Ooh. Well, how did I get a plus? Oh, that should be a plus. Negative times a negative is a plus. Plus 14. Watch your negative so you're not like me. Did you see what I did? A negative 4 times a negative 4 is a positive 16, not a negative 16. That would have messed this problem up. Okay, this is factorable. This can be unfoiled. You either need to do the box method or the group method. You need to go and pause the video and see if you can factor this. Do your magic X, do the box or the group, and figure out if you can factor this. If not, you want to go back and review that section. So the factored form of this is x minus 2, parenthesis, x plus 7. Now we have to do the zero product property. We have to figure out, there's 2 solutions in this. It's a quadratic. This is where the parabola crosses the x-axis. I think it crosses in 2 places. Let's check it. So x minus 2 equals 0. And then x plus 7 equals 0. So then when you solve it, you get x equals 2 and x equals negative 7. Now this is where we have to check it. Now this time you're right. We have to check it twice. So get over yourself. Here we go. Let's go back to our original problem. The square root of x plus 2 equals x minus 4. But we're going to check it twice because we have 2 solutions to see if it's true. In the first one, we're going to do square root of 2 plus 2. Is that equal to 2 minus 4? And some of you can already see whether that's true or not, and some of you are going to have to go all the way to the bottom. So this is going to be 2 plus 2 is 4, so that's the square root of 4. Is that equal to 2 minus 4? Well, 2 minus 4 is negative 2. 2 does not equal negative 2. Therefore, this is an extraneous. X equals 2 is an extraneous solution, and I'm going to cross it out. Okay? That doesn't mean I'm done and that the absolutely negative 7 is the answer. I could have no solutions here. If nothing works, there's no solution. So let's check our negative 7 now. Same equation, negative 7 plus 2. Is that equal to negative 7 minus 4? Uh-oh, did I factor that in? I factored it. Oh my gosh, I made 2 mistakes in the same problem. This should be -7. So this should be -7. And some of you probably saw that and you were waiting for me to catch it, because in class you would normally catch it for me. And I don't have anybody watching what I'm doing here. So it really should be +7. So go back and see if you can find my mistake. Okay? I knew when I was checking it because I've done this problem already. So the question is this true? Is the square root of 9 the same as 3? And that is true. And therefore, this is a correct solution, as long as you did your algebra correct. And you have to be careful. You saw what I did. I factored incorrectly. I was going too fast, and I factored out a negative when I shouldn't have. Let's try one more. That's pretty complicated, and let's just go through this one. Number 4. Oops. Number 4 is 4 plus the square root of m minus 2 equals m. Okay? Again, if you try to square at this step, you're going to have a mess. You can do it, but it's a mess, and you better know your algebra really, really well in order to do it. The simpler way is to subtract 4 from both sides to get the square root by itself. So we have the square root of m minus 2 equals m minus 4. In order to do a square root, we square both sides. Okay? If I square both sides, the square of a square root just leaves it out, m minus 2. On this side, we just talked about this. This means m minus 4 times m minus 4. So you either have to FOIL or box it. So that gives us m squared minus 8m plus 16. Let's see if I can do this one right. Okay. It's quadratic. As soon as you see it's a quadratic, you might as well get used to it. You're going to have to move everything to the other side. So I'm going to subtract m from both sides, and I'm going to add 2 to both sides. Now I'm nervous. I'm going to make a mistake. So we get 0 equals m squared minus 9m plus 18. You need to factor it. You need to do your X box. You need to do the box method or the grouping method, or any method that you figured out how to factor, and then you need to factor this. This factors into m minus 6, m minus 3. If you can't factor, you're going to get a lot of these problems wrong. So if you need help factoring, you can go look. I believe I have a lesson on factoring. If not, you can Google Meet Me, and I can teach you factoring again. Zero product property. M minus 6 equals 0. M minus 3 equals 0. So add 6, add 6. So m equals 6 plus 3 plus 3, m equals 3. That looks great, but we have to check to see if we created an extraneous solution when we started messing with this equation. So we go back to our original equation, 4 plus the square root of m minus 2 equals m. And I'm going to check it twice. I'm first going to check it with the 6. So 4 plus the square root of 6 minus 2. I'm just replacing the m's with 6's because we think this is the one I'm checking right now. We think that's the answer. So I'm going to ask myself, is this true? Putting a question mark to remind myself I don't need to move it to the other side of the equation. So then we have 4 plus the square root of 4. Does that equal 6? And again, you might be able to do this in a little shorter way. That's kind of up to you. 4 plus the square root of 4 is 2. Does that equal 6? Yes, it does. So that is not an extraneous solution. This one checks. Now we're going to check 3. And just because 6 worked doesn't mean 3 won't work. You have to check it. There could be 2 solutions, there could be 1 solution, or there could be no solutions. So you have to check each one. So 4 plus the square root of 3 minus 2. Does that equal 3? Okay, so we have, oh, I'm going to put my question mark so I remember I'm not moving. So 4 plus the square root of 1, does that equal 3? If you don't know the square root of 1, get out your calculator, do square root of 1 and see what you get. You get 1. 4 plus 1, does that equal 3? It does not, because 5 does not equal 3. So therefore, this m equals 3 is an extraneous solution that was a result of us squaring both sides. Okay, so this is a pretty difficult homework. I would do as many as you can. I would check my answers carefully. As you notice, I didn't give you the work this time. I gave you the answers. So you might need to meet with your teachers, and you might need to set up a Google Meet, and you might need to review this with your friends. You have to be able to do this because this is a skill that you're going to need next year in geometry. That's why we're making sure we're covering this right now. So if you have any questions, you know where to find us, and do your best to understand this.